There we go. Hello. Nice to see a few of you here for the live stream. As always, I enjoy if I can get some people interacting with me. If not, that's okay too. But I'm glad that some of you can make it for the live stream. Um, yeah, so we're in week 5, and I have a lot of stuff from last week to show you. So the project scores are out, um, and you guys did really good on that as a group. The vast majority of you did just really great on that project. So good for you. Um, I hope the experience was rewarding and not too stressful, but it may have been a new experience doing software and submitting it as a project. So those looked really good, and I worked really hard to get those scores back out to you as quickly as possible. So if you're not in the habit, I leave comments so you can go look at your score and see comments associated with it. And most people on the project, especially, will have gotten comments, but also on your labs. Sometimes it's things that I just think you're in a position skills wise where you can take the next step and improve some things. And I don't deduct points because it's not part of the requirements. And other times the comments are there to explain to you what's missing in terms of the requirements. So anyway, hopefully you look at those comments. I'm not going to spend a whole lot of time talking before we just start doing some demos. So yeah, let's look at some demos and just see what people did with their project submissions. There's some cool ones out there. So this person had a menuing system, which is kind of cool. Everybody, for your second project, you will all be doing menu systems like this. So you will have these same skills sooner than later that you can produce a menuing system like this. But let's go into the penny reducer. This person figured out how to clear the screen, which I should make a point of sharing that. Yeah, I'll hunt the little code down for that and give it to all of you. So how many pennies? So I tried a couple of, so for everybody's project too, I ran it at least 2 times with 2 different sets of inputs to test the results on. So with 50 of you, that's, well, it's more like closer to 60 of you. That's about 120 runs of project ones. And then the extra ones where I found bugs and stuff. So I gave everyone's this same treatment where I ran it manually. I looked at the outputs. I followed your instructions that your program was giving me. So anyway, there's this person. So I tried 99 cents on everybody, which should be 3 quarters, 2 dimes, 0 nickels, and 4 pennies. And this person has the fun little touch with the 25, 50, 75%. And they were just inserting those outputs after each stage of their own calculations, which of course goes so fast that you don't see any kind of lag in the timing. But it still looks kind of cool. So now we're back to the so how many quarters, and then they were clearing the screen between all, and then that should be 82 total pennies, and then finally you can leave. So very cool. Nice work on that. That's one. Let's get another one. Often, by the way, these projects, many of these people are people who communicated with me either in office hours or by Canvas inbox about their ideas for the project. So they were sort of out front of the curve on this project. So that's one thing that I want you to take away from the demos is not that, wow, these people are so talented. They were just born to be programmers. They're working at it. They are developing their craft. For 99.99999 whatever percent of us, programming is a craft. And the way you get good at a craft is you practice your craft. So if you are struggling, the way to get past that is to practice your craft. That's it. There's no people being born to be programmers or anything like that. These people are showing off their craft. So that's what we're looking at here. Okay, so this is the penny maker. Yeah, so oops, 2 pennies, 2 nickels, 2 dimes, 2 quarters. This one just has a nice, clean, orderly output. Things are lined up. It just looks really nice. See the commas, and then so 2 pennies, comma, 10 pennies and nickels, comma, 20 pennies and dimes, comma, 50 pennies and quarters, period. That is polish. That is good work. And at the end, this person also said you have 82 pennies. And oh, and by the way, look, it is 82 cents, if you want to think of it that way. Quite nice. And then I'll do 99 pennies for the reducer. And same idea, 3 quarters, 2 dimes, 0 nickels, comma, 4 pennies, period. Very nice work. And again, this is because these people have put the time in to develop their craft to this level where they're at right now. So this one also has kind of good output. So you notice the tildes and the asterisks and stuff. Just kind of slick. And there's my name coming back. There's the total of 82 pennies. It's perfect. And then we'll do the second stage, so all the calculations are correct. And they took some time to kind of put a little bit of pizzazz in their outputs. And I thought, well, that's pretty cool. I'm going to show that one off. Nice work. This one I like. Well, you'll see it. So you see how it says question 1, how many quarters do you have? Which means that it's likely that more questions are to follow. Question 2, nice touch. So that I know as the user that probably more questions are coming. Question 3, nickels, pennies. So that they're sort of numbered to show a sequence, and there's my 82 pennies total, and then so the second stage is taking a big bundle of pennies and breaking it out. So the calculations are correct. And anyway, that one just looks nice. Okay, last one. So all of us can do work of this quality. It's just a matter of how much time do you put into it. And you may decide that you don't want to, and that's fine. I mean, it's not a judgment on anybody. It's just this quality of work takes time at the keyboard to produce it. So I at least want to celebrate that about these people, but also maybe to encourage some of you to take a little bit more time at it so that you also can sort of produce results that you can feel good about, like these people no doubt do. This one is cool. They put the little, I don't know if you can see it in the screen, but Go will let you print emojis and special characters and stuff like this. So they found the little, that they could print out the little cents for 82 cents symbol. Pretty cool. Would you like to tell me a total number of, yes. Anyway, then there's and of course I'm using it on the squish screen, so for everybody I went into full screen mode so that your formatting would look good. I don't know if you could see that on the stream or not, but anyway, those are really, really good ones, and those are very pleasing for me to evaluate because I respect the amount of work it takes to develop skills that you can do that. So that's good stuff, and you all have that ability to do that. Everybody can do that. It's just a matter of putting the work in. Okay, so this doesn't apply to that many people, actually, but I'll just put it out there, and this is probably to people who never watch the lecture video, so I apologize that those of you who are here live or watching the lecture video later, you already know this. But in case I can pick up one of the strays, people who have strayed from watching the lecture, If you struggled on the project, do you watch the lectures as a habit? Because we gave hints, especially for the part that involved mods, the modulo operator. I gave hints about that in last week's lecture. Have you messaged me in Canvas inbox with your questions? Have you come to office hours either by scheduling one-on-one time or doing the drop-in? Have you gone into Piazza and posted a question there so that me and your classmates can help you? You have these channels of communication that you can reach out and get help through. So if you found you struggled on the first project, I am positive, because I know who struggled on it, you didn't use any of these channels of communication. So don't let those channels just sit there empty. Use them. Okay, so I have to move the agenda because I have now lab demos from last week. So the big problem with the week 4 labs that I had while grading them is that I would run people's programs, and the programs would not give me any instructions on what to do. Please enter 2 integers. Okay, well, I'd enter an integer, press enter, and then the program would crash. What am I supposed to do with that? So I would go poke around in the code and realize, oh, what they should have told me to do was put an integer followed by a comma, followed by a space, followed by another integer, or whatever it was. But if you are doing something that the user can't read your mind about what they're supposed to do, tell them on the screen. So some of these demos are going to show that, just so you can see what that looks like. But if you're in doubt about whether or not the person who's running your program knows what to do, tell them what to do. Let's see. But a lot of these are just going to be kind of look nice or had an interesting idea to try out. So let's have a look and see what... I like the way this person has sort of developed a style about doing prompts. So notice the little caret. That's a cool idea. And in this case, they just kind of themed it a little bit. So my lucky numbers, by the way, were 1 and 2. Okay, so notice here it says enter both numbers separated by a space. That's how you give your user instructions. Okay, so I've been told enter the 2 numbers separated by a space, so I am going to do that. And if I do that, then the program runs as expected. So a lot of people got docked pretty severe points because they didn't give me any instructions. I guessed as to what their program wanted me to do, and then the program most of the time would crash or produce garbage output. And that's as far as I'm taking it. So I evaluated what I could, and I didn't fight trying to mind read someone in some other part of the world. So just think about that. If your program is not clear about what you want your user to do, you can fix that, like these people have done. So here's another, what floats separated by a space. Okay, fine. I can do that, and it produces good results. So that's an example of how you can, and this is that from one of your classmates who made their instructions clear. And they didn't do anything elaborate or fancy. They just said, hey, a number, space, a number. So I did it, and it worked, and all was good. Here's another one. So just kind of reminding the user, like, we want whole numbers here. So I'm going to do whole numbers. I like the way this person kind of produced this table. They also, by the way, do you notice that they showed addition, subtraction? They showed all the operations from both directions. So they switched the 2 outputs and showed them in both directions, which is super cool. So now decimals. And then they did the same thing here, where they made this little table, and you all can do that. So knowing that you all can do that, then this would be sort of a source of inspiration, perhaps, to see this and think, I could have done that, and I can do this going forward because I have all those same skills. So nice work on that one. And I don't remember why I selected these particular ones, so I have to get them running again to see. Oh, nice. So there, enter a value for X, enter a value for Y, So see just how clean and simple this program is. So it asks me for an input, I give it. It asks me for another, I give it. It prints out the values I entered. It does the math as instructed, and nothing fancy, nothing special. Just exactly what was asked for. So that one did exactly what was asked for. They added a little bit of flavor text at the end with my name, which was a nice touch. So again, I'm glad that a lot of you, and this is true for a lot of you, you are enjoying the skills that you're developing and you're using them in your labs and your projects, which I hope is very rewarding. It's cool to see. Anyway, just a few more. So this person has also kind of developed a user interface style. So they ask the question, they have a dash, and then I put in my data. So this person themed theirs a little bit. So I'm just going to say I'm 1 year old. So that's all. They're just asking for 2 integers, but they asked them for whole numbers, and then did the math, and even sort of added some extra flavor text around it. So awesome, you entered. Let's start with addition. Next we'll do subtraction. Now we'll move on. That took work. And that took work applying the same skills that all of us at this stage of the semester have. So quite cool. Anyway, just a really nice extra sort of outputs and some thoughtfulness in the application of this person's skills makes for a very nice submission. So good stuff. Some more. So this one has Jeeves' personal assistant kind of flavor text, a theme to it. So integers, an integer, a second integer, it does all the math, it reverses them. This person grouped up the reversals, which is a nice touch. I do the floating points. They reversed the floating point numbers as well. So just good, nice program. Well done. And then last one, and then we'll move on to content. So I hope that there's some people out there watching thinking, I can do all those things. I can produce those outputs, and I can insert the values of variables into them. And I can also use the arithmetic operator. So I can do all those things. And it's a good feeling. I think you'll find that you are rewarded more than I am for taking the time to do it. So here's another one. 2 whole numbers with the space in between. So the instructions are clear. It doesn't just say 2 whole numbers and then crashes when I try to enter one. It's very clear. There was one, for example, that said enter 2 numbers with a comma and then actually showed an example of what that should look like. And I did that and it worked. There was another one that said enter 2 numbers separated by a comma, and I did that and it crashed because it turns out that's not what the program was written to do. So the way you can uncover these problems in your own programs before you submit them is to run them, and to run them many times. I run these programs many times in evaluating them, and you're just you and your one program, so why not spend a little bit of time just running through it several times and looking at what happens. So here's another one, decimal numbers with the space. I'm perfectly fine with that. The instructions didn't say you couldn't do that. But the instructions also didn't say, make me wildly guess and read your mind. So some of you lost some points because the program didn't run. It didn't instruct me what to do, and it crashed, and I evaluated what I could do up to the point where it crashed. So this one gave me good instructions. I followed them, and it works perfectly. So good stuff. Okay, so that is the week 4 lab demos. There were just so many good ones that I could have shown, like 90+% of your labs as examples were just good. But there was a small number of people who I wrote this question for, this tip. Does my user know what to do? Have I told them what's expected of them? they're not mind readers. I'm not a mind reader. And so I need your help. If your program is expecting some different configuration of my inputs, then tell me. Otherwise, I'm going to guess, and if I guess wrong and your program crashes, that's where the evaluation ends. I'm just not going to take the time in life to guess the million different configurations you might have selected, or stop and go read your code, which is always the second stage for me. So I always run these programs first and evaluate them with a variety of inputs, and then I go look at the code so I can give you feedback about how your code is looking. But first and foremost is, does the program work correctly? And then we worry about, did I do it in the best way possible, and is my source code formatted, those kinds of things. All right, anyway, so there's demos. 90+% of everybody on the projects and the labs did just great. So if you didn't do just great, you have plenty of time to get yourself on the rails that you would like to be, I hope, to get help to sort of get going in the best direction. Okay, there's demos. So I've scrolled the agenda, and it's a short agenda. It is a new technique, and we'll just kind of build up on it over time. But this is largely, for now, this is a way to better organize your programs. And I'm going to sort of have you approaching it from that perspective for a while. So we're adding a new technique. It's called the function. We're going to create functions and use functions to build programs out of. And what you'll find is, as the programs that we write get bigger and bigger and bigger over the course of the semester, these functions will help you kind of chop up what would be otherwise a very large program into smaller interacting component parts. So kind of like an assembly line, but in software. Okay, so let's, so before I get into Replit and start doing code-like things, let's look at the module. So I'm going to just double check and make sure I'm showing you what I want to show you. I am. Okay, so let me blow this up. Blow it up, please. There. Oh, that's good. So what I want to show you here, we are in week 5, and we have some weeks before the second individual project is due. So you might want to break because you crammed over the weekend to get your first project done, which just about everybody, by the way, submitted a project, which was also very, very good. So even if your first project didn't get the result that you would have liked, that you submitted something was good, was great, because now you don't sort of have that as a big setback. You move on to the next one. So we have 1, 2, 3, 4, 5 weeks before individual project 2 is due. But what I hope that you will do is you will read this project 2 this week. You will go read its requirements. You may find that every last requirement in it is over your head or not, but you at least want to know what's coming, so that as we work through the modules for the next 5 weeks, you can look for the things that you need for the second individual project. You need functions. We're getting those today. You're going to need random numbers, which we're getting soon. You're going to need decision making. You're going to need repetition a little bit. So all those things for project 2 are coming up over the next few weeks. But you want to preview the project by reading the assignment so that you know, so you can kind of shop for the skills that you need. Let me shrink it back a little bit. Okay. So anyway, just keep that in mind. And the projects and the modules are designed to go together. So the next 5 weeks, we are developing the skill set that, brought all together in one place, is what individual project 2 will have you use. I'm excited about this week, by the way, because once you come to understand what a function is and how to create and use functions, it is very difficult to program without them anymore. They just make so much sense. Once you get to that point where they make sense to you, then they make so much sense to you that you can't imagine not using them anymore. So I'm excited because that's kind of where my brain wants to go is I would love to make a function here, but we're not there yet. So I'm having to sort of fight that off. And hopefully that happens for you too. By next week, I hope that you're beginning to think, okay, I got to write a program. I'm going to need to create functions for it. That's our goal. Okay, so we're going to define what is a function. What are the building blocks in terms of what do you type into the program that make a function? How do we create them, which we call implementing them? And then how do you use them, which we call invoking them? So we're going to create / implement functions, and we are also then going to invoke / use them in our software. Readings, as always, and sort of from different angles so you can see different people's descriptions of them. Don't forget that you had a Piazza discussion where people went and gathered a whole bunch of tutorial videos and websites and stuff. So those, of course, are always available to you to supplement your learning. So the homework based on the reading. The lab I will come back to before we cut out, and we'll have a quick look at it and see if there's anything scary looking inside. Piazza discussion. So we're going to have a discussion about functions this week, which is often what I do is ask you to go kind of gather up more materials. So the more different presentations of what a function is and how to make them and how to use them, the better. So we'll do that in discussion. I'm also going to stop here and point out to you, by the way, I wrote this little preamble section about developing a solid understanding of functions. So what a lot of us who teach computer science feel is that this is kind of one of the big things to understand, and it's one of the more difficult things to understand. And I've never found the sort of the magic trick that can just make people automatically understand how to create functions and how to use functions. It takes practice, it takes repetition, it takes reasoning through them for yourself and trying to figure out your own words to explain what's happening for yourself. Discussion forum can be useful in this case because you can put words down that attempt your explanation of what a function is. So these functions are a big deal, and understanding how they work is a big deal because it opens up most of the rest of programming to you once you understand how they work. But for pretty much all of us, myself included when I was a computer science student, it takes a while to settle into what a function is and how to use it. So we will start with the most simple setup we can find, and then we will sort of make our functions be more complex over time. So by the end of the semester, you will have done all the things that you can do with the function. Today, we're just going to do 2 of the many things you can do with a function. So that discussion is important because you want to internalize these concepts, which means that you want to be able to have your own words that you explain what's going on when we think about functions. And this is meant to be a safe space, so you venture your explanation, and it may or may not be correct, and it may or may not make sense to other people, but it is a good way to begin to internalize this concept. And then the reminders, and I know you just finished a project, but the nature of a class like this is that we always have the next project to do until we've done the last one. So Project 2 is out there. You should read it this week. If you want to start it, that's great if you feel that you can. If you read it and you think there's more things going on in there than I know how to do, that's okay, but at least you know what's going on with it. Okay, so I'm going to go back to the lab and queue that up. Take a sip of water, and then I'm going to switch over to REPL it. Okay, so getting to the fun stuff, in my opinion. Athletic, luxurious worker. Week 5. So it turns out that you've been looking at a function the entire semester, and many, if not most of you, if not all of you, looking at the screen that I'm looking at right now, can find the thing that refers to the concept of a function, which is this thing here. Now, you may not have known it was the whole thing, but hopefully you saw this keyword. Keywords, by the way, when we say keywords in programming, we mean a word that is actually built, it is a part of the language itself. So this keyword func, it has a specific meaning in the Go language, and you can only actually use it in specific places where this particular thing can be used. So we call those keywords. Package, you can see at the top of the screen, is also a keyword. It has a specific meaning in Go, and you can only use it for a specific thing. Import is a keyword. You can see it has a specific meaning, and you can only use it for a specific thing. And they're all blue in Replit. So those are keywords. So when I say that, I mean a word that's kind of built into the language. To contrast that, by the way, when you declare a variable and you give the name a variable, like first number to be entered, var first number, int. First number is not a keyword. That is a variable name that you, the individual programmer, chose for your specific program, but that word is not reusable across every Go program in the world. This keyword func has the same meaning in every program written in Go. Okay, so it turns out that the whole thing that I've highlighted is a function. Many programming languages do it this way. So C++ does it this way. Java does it this way. Python does it this way for all intents and purposes. Many programming languages have what is called the main function. And they often use the word main to name that function. So in the Go language, this main function, you will find it in every application in the Go language. It's a special function in that it is always there. It will at least always be there for us. And it has a slightly different usage than the other functions that we will create. But the basics of it are the same for all functions. If you want something to happen inside of your program, you put it in here. So if you want an output, you put it inside of this section that has been marked off as function main. And if you want another output, you put that in there, and you just keep going and going and going and going and going, of course. And when you get to the end, everything in between these curly braces is your application. Okay, so that main is a sort of a super powered function because every application that we create is going to need it, because it is the one that Go sort of looks to automatically to find the stuff to do that's a program. So when you click run, what happens is Go finds func main, and then it starts executing the instructions that are inside of it from the top to the bottom. Okay, so what else do we have? We have these curly braces here. This is called a block. So every function has a block associated with it, and the block is marked by a opening curly brace and a closing curly brace, and then you place everything that you want to associate with that function in between the curly braces. So we would say about the function main is that everything we want our program to be up to this point has been inside of the block of the main function. The other thing that I've been pestering a lot of you about, by the way, is that everything inside of this block be tabbed over once, which is true for all functions, by the way. Okay, so we have the keyword func. That's how we set up to create one of these things. This is the name of the function. In this case, the name of this function is main. This parentheses is always present for a function as well. We call this the parameter list. I'll label. So that the words are clear. And I'm going to line these up because it's going to bother me if they're not lined up. Okay, so that's all the components we're looking at here. Func, that is a keyword in the Go language. It is used to create a function. Main, that's the name of this particular function. The parentheses, that we call the parameter list. You'll see an example of usage of this. We call main's parameter list an empty parameter list because it's just parentheses with nothing inside. So before we're done today, we will put some things inside of this parameter list. But this particular parameter list is empty, and it has to be there even if it's empty. And then finally, the curly braces and all the stuff between them, that we call the block. Okay, so that is all the components of a function. And of course, we know that what we do inside of functions is two new lines I will put after that. What we do inside the block, of course, is we put executable Go code. So now I put some executable Go code, which is this one printf, which will print this program demonstrates functions, and then two new lines after. So when I click run, Go is going to find main, and it's going to execute everything in it from the top to the bottom. So we'll prove that. You all know how this works. And the reason why there's the extra blank line in my output is because I put two \n/n. So one of them went down to the next line, and the second one is what pushed the little yellow caret down another line. So run does what? It causes everything inside of main's block to execute. Okay, so now let us create a new function, not main. So I'm going to go up here. This is after the import and before main. And notice that the main block, that whole section, is completely separated. Now, I'm not crossing these things over. I'm not spilling one block into another block. So we'll inspect this code carefully once I've written it. But it's after the import stuff and before func main. I'm going to leave these notes here. Take out the blank line for reference for later. But let's create a function. So how do you do that? You use the keyword func. That's how we tell Go, I want a function. Now, when it's not main, we can actually give it whatever name we want. The name for functions is the name for variables, except for we should be more careful that our function names are descriptive. So sometimes when we're creating variables, we might say var x int, var y int. With functions, never do that. Never, ever, ever do that with a function. Always make your function be a word or words that explain or describe its purpose. So I'm going to call mine say hello. That's the name of my function. Notice that I've used the same naming pattern as I would with a well-named variable. So I start with a lowercase letter. I use camel casing so that I can smush the words together per the rules. But it still have now a descriptive. So this function's job is to say hello. Okay, so I have the keyword func. I have chosen the name for my function, which is different from what main is, because main has to be that way. But when I create new functions, I can name them whatever I want, but I should name them descriptively. Parameter list has to be there, even if it's empty. It's just an empty set of parentheses, but it has to be there. And then a block. And then what REPL will do is it'll actually automatically close it for you, and then you press enter, and you're ready to go. So there's my say hello function. It has the keyword func so that I could create it. I named it. So just like I name variables, I got to name my own personal function that I'm making. And I used a descriptive name for it. I put an empty parameter list because you have to have a parameter list even if it's empty. And then I put a block to mark the beginning and the end of the instructions that go with this function. So this function doesn't do anything yet, but I'm going to put some instructions in it so that it can do some things. So hopefully that all makes sense. This is as simple as you can make a function in Go. Something else you're going to notice, by the way, since we're in a block, everything should be tabbed over once. Just like in the main block, everything is tabbed over once. And if you're not in that habit, get in that habit. I'm going to start being tougher about that on the remaining projects because when you exit this class, I want you to be a competent programmer, which includes style. So everything in a block is tabbed over once. So what do we want say hello to do? Well, it's probably obvious what it was going to do, which is hello. Maybe I'll put a new line there. So there's my function. It does one thing, which is print hello. I don't think I need to label it up, but you can kind of use the notes that I wrote for the main function and apply the same idea to the say hello function. All right, I'm going to press run, and we will inspect what happens. So notice that hello never printed. And this is now the second stage of this process. So hello never printed, even though I have a function that prints the word hello. When I ran the program, the word hello didn't appear. So why is that? So this is the second stage. In fact, I will label it that way. So stage 1, implement, create a function. So we did stage 1, which is we implemented, or if you like, created a function. But we notice that when we click run, Go doesn't execute this print statement, hello. So now we need to go on to stage 2. So this is a little bit harder, but not a way harder. So how do you make a function actually do its thing? Well, you have to do stage 2, and you have to do it in a place where Go's going to run into it. So we know that when I click run, Go looks for this main function and executes everything inside. So somehow I need to get Go to execute this block of code from this other block of code. So this is stage 2. Invoke, call, or you might like the term use a function. So stage 2, after you've implemented the function, is to invoke or call it, or use it. So what we mean by invoke a function is cause it to execute. Some people will say call the function, which also means cause it to execute. And if it helps, you can think of it as simply using the function, which is also causing it to execute. So I'm using all these terms interchangeably right now. The fancy computer science term for stage 2 is invocation. We are going to invoke a function. But you'll hear some computer scientists and programmers say you need to call the function, which is the same thing. Okay, so how do we do that? So to invoke a function, we use its name. Notice I did not use the keyword func because the keyword func is for creating or implementing the function. To invoke the function, all I do is I use the name of the function and then the parameter list. So this is telling Go from main. So what Go is going to do is it's going to print out this program demonstrates functions, 2 new lines, and then it's going to encounter this call or invocation of the say hello function. And what this is telling Go to do is find that function and execute what's inside of it and then come back. We'll look at the come back part in just a second. So this will cause Go to go locate the actual implemented function and execute the instructions inside of its block. So we'll run that and it will say hello at the bottom, and that's because we are now invoking the function. So Go always finds main automatically and then begins executing stuff inside of it. Sometimes executing stuff inside of main means jumping up and executing stuff inside of other functions. Now the cool thing about this is that you can ask Go to use that, to invoke that function as many times as you want or need to do it. So I'm going to have Go up and execute it once, and Go's going to then go up and execute it a second time, and then Go will go up and execute it a third time. So there are the 3 hello, hello, hello. All right, so we're going to add one more little wrinkle to all this to try to help you develop an understanding of it. So every time we invoke a function, Go will go find it and execute what's inside. Now what happens after a function has been invoked? Go returns to the location where it left off and continues. So when Go has to leave for this first say hello, it goes and it executes it, and then it comes back to right where it left off and continues. And I'm going to prove that by putting some print statements around it. Okay, so let's see if we can understand then what happens when I click run. When I click run, Go automatically looks for and begins executing the contents of main. And it does it from the top to the bottom. So it's going to start with this first one at the top. This program demonstrates function, 2 new lines. And then it's going to keep going. The next thing it's going to do is first hello, ... new line. Then it encounters say hello being invoked. So it has to go up and execute the say hello block, and then it will continue where it left off. So Go will come right back here and continue where it left off, which would be on line 23 next. Then it will say second hello. Then it is told to go up and do say hello again. So it will jump up here, execute this block, and then continue where it left off, which is the next line down. Third hello. It's told to go back, execute it a third time, continues where it left off, and finally this last printf. So one of the things to understand about functions is that it is automatic that when you invoke a function, Go will leave temporarily, execute it, and then come back to where it left off and keep going. And here we can see, so there's this program demonstrates functions. There's first hello, there it leaves to execute the function, and then comes back and picks up where it left off. And then it leaves and executes the function, and then it picks up where it left off, and then it leaves for the third and final time, executes say hello, and then it picks up where it left off. So that's quite powerful. That Go automatically picks up where it left off in main. Good stuff. Okay, so that's a lot of hellos. Well, I'll leave them. So let's do another function. So let's do a say goodbye. So how do I do a say goodbye? Well, I'm just going to go up here and I'm going to find some space either above or below say hello, but separate from it. So make sure that you are not causing these blocks to cross over each other. So there's the main block, completely separate from the say hello block, and then I'm going to create a say goodbye. So I'm in stage one again. I'm creating or implementing a function. So func, I'm going to call it say goodbye because that's what I want it to do. So that's my name because it describes what I intend to do with it. Empty parameter list, space, block, press enter, and I'm ready to implement what this function says wants to do. So in this case, I think I will say goodbye. And in fact, let's also then leave them with a nice, have a nice day. So say goodbye, I'm going to do something extra in. And what you're going to find, by the way, is that just like main got big for project one, your separated functions are also sometimes going to have a lot of stuff going on in them. So it can be more than one thing that a function does. It can be many things, in fact. So this, we're just going to add and do two things. Say goodbye. So now I have two functions besides main. I have say hello function. I have say goodbye function. That's stage one. I will run it, and we will note that the program never says goodbye, and the reason for that is that I never invoked it. So I have implemented it, but I never invoked it anywhere in the program itself. So if I want my say goodbye to happen, I need to find a place to invoke it in main. And I think where I will do it is the last thing in main. So how do we invoke a function? We don't use the keyword func. We do use the name of the function. We do use the parameter list, even if it's empty. And that's an invocation. That will cause Go to jump up, execute it, and then come back to where it left off. In this case, I'm not going to have Go do anything else. That's just going to be the end of the program. All right, so there I am invoking the say goodbye function. And here it is. Because it says goodbye, 2 new lines, and then have a nice day, and then 1 new line. So there's my goodbye function in action. I'm going to put an extra new line here. And I'm going to take the extra new line out of the function. So those two are kind of grouped up together. That's better. Okay, so that's the simplest kind of function. And the way we would say that, the simplest kind of function is usually a function that has an empty parameter list. It's going to get slightly more complicated here when we put a parameter list into play, but let's do that. Oh, by the way, once you start using functions, you will find a new feature in Replit. So if you go up, oh, is it going to do it? Oh, it's not going to do it for Go code. Huh. Well, I didn't know it wouldn't. Oh, well, never mind. Okay, let's make a new function, and now let's add a complication to the mix. So what if I wanted to, for example, say, hello, person, And I wanted to refer to a person by name. How could I do that? Well, I could just say hello Boyd, but that's a terrible program, because what if some other person but me were to run my program and it says hello Boyd to them every time? So what we'd rather do is figure out some technique. In fact, well, yeah, let's leave it like that for a second. And also maybe it'd be nice to say goodbye, person. But instead of the word person, wouldn't it be nice if it were the name of the person that we had maybe gathered when the program was running? So let's do that. Let's make a function that can say hello to the person by name. And I'm going to just, actually I'm going to put it right here between these two. So I'm going to say func say hello to person, empty parameter list, the block, and I'm going to take this code so that I can put the old hello back to just hello. So now I want to say hello to a person. Now, how do we make this so that we can plug and play the person part? If you know Mad Libs, how can we make this person not just say person, which is very impersonal? How do we say it specifically to a person? Well, pardon me. Well, what we'd like to do is, let's say, have a string, and then we will print out that string like we've learned to do. We still have a problem here because it's always Boyd still, and that's not what I would prefer to have happen. So how do we make it so that this function becomes more flexible so that we don't always say hello person or hello Boyd over and over and over again? This is where parameters come in. So will be parameterized I'm going to change these words for a second, but since we're on a video, I want you to be able to read this. So the process that I'm about to go through is called parameterizing the function. We parameterize functions when we want to make them more flexible in their usage. So why is this function presently inflexible? Because the name is always Boyd. And that stinks, because what if someone who's not named Boyd calls this function and it says hello Boyd over and over and over again? So we want to parameterize this function so that it doesn't always say Boyd necessarily. The person can change. So the way we do that is where we would imagine that we were using a variable in the function itself, we get rid of that and we put that variable in the parameter list. So notice there's no var here, and there's no equals Boyd part either. So, but it is basically a variable. But it's a special variable because it's a variable that's connected to the parameter list of a function. So we have parameterized this function. Now the function is parameterized to accept and use different person, which is this string here. So this is how we begin to make functions more flexible, is that we parameterize them. We take those parts that we would like to swap out and we parameterize them. So the part I want to swap out is the person string. So I put it in the parameter list. I strip off the var, I strip off the equals Boyd, but I leave the reference to it in the printf. And Go will know how to pair these things up with each other. So there's stage one. I have parameterized a function. Now let's go call it. I am going to disable this stuff for the time being. So let's go into main and call the function. So what we've been taught so far is we use the name of the function, say hello to person. Is that what I named it? Yes. Say hello to person. And then empty parameter list, but this time it's different because I'm supposed to put a string in there, a person. Okay, let's do that. Turns out it's going to be Boyd the first time through. But let's see what happens with this Boyd when this function executes. What I'm hoping is that Boyd will come in the place of person, and then Boyd will be inserted into the output. And it worked. There's the hello Boyd. This is complicated to get straight in one's head. How the heck did all that happen? Because it seems like there's a lot of magic, because there's in no way did I sort of directly connect the pieces. And I know this causes difficulty for just about all of us, myself included. It's hard to see how did those things connect themselves. And Go did it, and Go did it where we can't see Go doing it. So we just have to understand how Go is going to do it. So let's take this out, though, and just see what Go says if I try to invoke this function without a person in it. Okay, so not enough arguments. So I'm going to use these terms interchangeably for a while, but when you see Go say argument, that's referring to parameters. So arguments and parameters, for the time being, we're going to think of those as interchangeable terms. So main, no arguments or parameters. Say goodbye, no arguments or parameters. Say hello, no arguments or parameters. Say hello to person does have an argument / parameter. It's labeled as person, and it is a string. So Go is recognizing something here. If you notice, Go says I have empty parameter list, but I want a string in there. So Go actually recognizes, hey, you're supposed to plug a string in here. And then how do I know what string to put in there? And when to put a string and all of those things. This is not easy. Just be patient and give yourself time. But I can tell that Go has already kind of warned me, hey, you can't say hello to a person if there's no person to say hello to. The way Go sees that is I'm giving it an empty parameter list, but it wants a string in there. So Go is basically reading this function as a rule. So Go looks at this function and says, hey, this is a rule you have to follow. Say hello to person requires a string who is the person you want to say hello to. And Go in stage 2, which is the invoking part, is actually holding me to that rule. So in stage 1, when I create the function, I get to make the rules. So I made a rule that I want to have a person I can say hello to. Stage 2, Go is actually enforcing those rules on you. So that feels funny because, hey, I made the rule and now Go is enforcing it on me. Can't I break my own rule? And the answer is no, you can't. So when you do stage 1, you make the rules. When you do stage 2, Go enforces them on you. So Go is saying the rule is there's got to be a string in there. All right. Fair enough. Will it take Jane? It will. Will it still take Boyd if I invoke it 2 times? And remember what it does is it's going to invoke it with Jane as the person and then come back right to where it left off and then invoke it with Boyd as the person. It did. Can I do this? I don't know. I'm running out of names. Jane. Mary. So can I do this? Can I actually declare a variable down here, plug the variable in, and have the function use not its own person string, but this person string instead? And it will. So this is going to take a while to get used to, but every block is kind of its own little mini program. And blocks can actually declare variables for themselves, and they can even declare similar or same variables for themselves, and they won't cross up the other blocks, which is kind of a cool thing. So I can also say hello to a person using a variable that I have created. Can I do this from user input? Can I do a format.printf? Who should I say hello to? Format.scanf. I'm going to scan in a string, \r\n. There might be a few people who are putting the wrong slashes in here. That's wrong. So it's backslashes. And then the person. So can I go and scan that information from the keyboard and then say hello to the person that way? So what I'm hoping to see is hello Jane, hello Boyd, hello Mary, hello whatever it is I choose to type in here in just a moment. So who should I say hello to? I don't know. Mary, Mo. Yes, I can. So I can actually take what the user typed in, scan it, and then send that along to the function, and it will take that and plug it in. So there's a variety of ways to explain this to yourself. I have my way. You may agree that my way is okay. You may decide that my way doesn't make sense to you. But work on this problem of how do I explain to myself how Go is actually taking Jane, plugging that in as person, and then immediately after that taking Boyd, plugging that in as person, and then taking this person, plugging that in as person with the Mary in it, and then finally taking what they type in and plug that in as person. So to me, I just think of Go as taking the data that it has in main and plugging it in. But that may not work for you. That's kind of, we all have our ways of explaining it to ourselves. Okay, so there's a function that has a parameter. Let's do one more and then we'll look at the lab, I think. So switching back to the stage one part, I'm going to make one more function. I haven't decided what the function is going to do. But let's try a function with a couple of integers. So let's say do math with a couple of integers. So I'm going to do something slightly different this time. I'm going to put two integers in here, an x and a y. So I'm in stage one, which means that I'm making the rules. And I'm making a rule that says I need you to plug in two integers for this function. You're going to recognize this because it is from the lab last week. So I'm in stage one, which means I am implementing a function, which means I am effectively making the rules for this function. And then when I switch over to stage two, Go is going to enforce my own rules on me. So what will we do with this math? Well, let's print them out. So the numbers are %d and %d, period, new line. And then I'll plug in x and y for the 2%ds. Maybe do an extra new line there. And then I'm going to do the math with them. So format.printf. Yeah, so %d plus %d equals %d, new line, y, x plus y, and then I'm going to copy and paste this a few times. We're going to plus, minus, times, divide, modulo. Mod has to be twice to show up on the screen. Divide times minus. So you'll recognize this as part of the first sequence from lab 4. So I've gathered together all that integer math into a function. So this is stage 1. I have implemented or created a function. Notice there are now 2 integers, x and y. I'm going to take those integers, x and y, and I'm going to plug them into a whole bunch of different things. All right, so now let's switch gears. Let's go to stage 2, which is now I'm going to invoke the function. So I'm going to go down to main. I'm going to get rid of some of this junk. And I'm going to invoke the function. Do math. I can always start here, the name of the function and an empty parameter list, and then I'll click run and see if Go is happy with that. It is not happy with that. Not enough arguments. So it has nothing. It wants an int followed by a comma followed by another int. Well, let's just be jerks and try one integer and see if Go will be happy with that. It's telling me pretty clearly I need 2 integers, but hey, let's try it without. Nope. So I gave it 1 number, but it wants 2 numbers. So fine, fair, comma, space. So what happens here is when Go receives this 1, 2, it's going to plug in the 1 for x. There's the comma. Plug in the 2 for y. So you're going to see 1 and 2, 1 and 2, 1 plus 2, 1 minus 2, 1 times 2, and so on for this invocation of the function. And there it runs off and does all the things. Let's see if it will work with variables. X int equals 10 var y int equals 3. Do math x, y. And you just have to kind of work out, reason out in your head what's happening here. So what Go is actually going to plug in is the 10 and the 3 here. And then the function will also then plug in a 10 and the 3 in those same locations. So let's run it. So that works. Will it do it with user inputs? I forgot a quote. Okay. And then I'll go ahead and do math with the x and y. And remember, since Go is executing from top to bottom, it will have stopped and gotten the user to type in some stuff here before plugging what the user typed in. So let's run it and see if that works. Oh, okay. So it's waiting for me to type in something different for x. I'll say 99 and 25. And then the function, noticed that it fired off with my 99 and my 25 on that last run. And that's just to show you that when you are plugging in arguments / parameters, you can plug in literal values, actual values. You can plug in variables. You can plug in variables that are entered by the user. You can also, by the way, plug in combinations of those things. So I can say 1 comma y. I can say x comma 1. I can also do combinations of those things. And the function is more than happy to use all those values. So I'll just do a 50 and 2. And then you'll notice that it is, there's the 1 and the 2, there's the 50 and the 1. So Go is happy to take all of these different combinations and plug them into your function so that the function can take those values and do its instructions. It's pretty fun. I will upload that as a sample. I'll worry about saving it later. Okay, so I'll update this so it's on the screen for a few moments, but for now we're going to interchangeably use the term parameter with the term argument so that when you see an error that's talking about arguments, you know it's about something that goes in those parentheses. Okay. Last thing, let's look at the lab and see if there's anything weird going on in it. Okay, so this to be careful of. Notice in the agenda it says, read the documentation for each function. Do no more and no less than is required. So if we look at, for example, this hello world function, it's got some notes above it that tell us about what it is, and it's also got something specific inside about exactly what is wanted. So this function, hello world, empty parameter list, it's capitalized and that's fine. Empty parameter list. So it is supposed to do the instruction that would print capital H hello space little w world exclamation point and a new line. Almost all of you know how to do this without any assistance. You're just going to be doing it inside of the block of a function. All right, what does the greet user one do? Looks pretty familiar, doesn't it? Greet user prints the message hello person, but notice here, so we want to print hello person, hello space person exclamation point followed by a new line, but we're not using person in all caps. We're actually plugging in this person, which we just did and extended an example of. So you're going to see something very similar in greet user. Notice that it's got a capital G on it. What is the next one? Estimate age. So it's going to print a message that says, I estimate your age to be something, followed by a new line. Maybe I will offer an example of this. Before I let you go, we're doing okay on time anyway. What? Oh yeah. Raw. Okay. Yes, better. Okay, so let me give you some help. Hello world, we just did one. Greet user, we just did one. So estimate age, and it accepts a birth year. So this is a video only hint, which you're welcome to spread the word if you know of people who don't watch the video ever. This will be the tell because I'm giving you a solution here. So this one has an extra step in it that we haven't looked at yet. So the way you do this, though, is you inspect the function as you receive it. You read the documentation. So estimate age prints a message. I estimate your age to be age. If I see something in all caps, there's a good chance that I'm going to be asked to plug something in there, followed by a new line. And then we are receiving a birth year. So compute a person's estimated age based on the birth year. So in this case, I have to do 2022 minus the birth year, but I have nowhere to store this information. And if I can't store this information, I can't then turn around and use it for part B. So how do we store information like this? Well, birth year is an integer. 2022 is an integer, so I need an integer. I'm going to go ahead and use estimated age to inspire my choice of names. Estimated age, that will be an integer, and it will be computed as this year minus the birth year. Where did the birth year come from? It came from right here. How do I know what that birth year is? It doesn't matter. Somebody somewhere is going to plug in a birth year right here, and all my job is to subtract that from 2022 to produce an estimated age, and then as 3b I will print that out. So what does it tell me to print out exactly? Well, if I'm in doubt, just grab it, put it in here. It says followed by a new line, but age is to be replaced by my computed value. Okay, well, my computed value is an int, and its name is estimated age. So there I've done the two steps. It turns out that for this function, I actually had to declare a variable inside of it so that I could run the calculation, and that's fine. And then I used that variable that I declared here for the required output, which is I estimate your age to be. I literally just copied this so that it would be exactly what is described. I followed it by a new line, and then I plugged in estimated age where all caps age used to be. Okay, compute average is going to be something similar. You have a points earned, a points possible. Notice, by the way, formatted to do decimal places. So this is all stuff you know how to do. You just haven't done it in the context of a function. So don't let go of all the stuff you've learned. You are using it. You're just using it in a different location than you're accustomed to. Let's go down to find estimate age in main. So declare variable, invoke. All right, here it is. Declare a variable, prompt for and read in a birth year. Can do. Birth year int, prompt for it. In what year were you born? 4 digits, please. That's going to be an integer, \r\n, the birth year. Okay, that's number 7. Number 8, so invoke that function estimate age, which starts with a capital E, so I need to make sure I match. Invoke estimate age. Always have parentheses, but then it tells me to plug in the birth year, pass in the birth year. If I run it right now, by the way, I may get just crazy amounts of errors. Oops, it's missing an import. Ooh, I better get an import. I'll update that in the project code right after I finish here. All right, so need that import. Not enough arguments in call to estimate age. So line 59, it says, I am invoking estimate age. I have given it nothing. It wants an integer. And it's kind of in programmerese telling me pass in the birth year. That's this thing. Fair enough. Why? Because Go is enforcing this rule on me. This function says, hey, I'm called estimate age, and hey, I need a birth year. Okay, so I got the variable, I prompted for it, I read it in, and then I'm going to pass it along to the function so that Go will be happy with me. So this is not when I was born. But I'd be 23 if I were born in 1999, estimated, right? Maybe not exactly. There's that function. That is live stream / video only, hint. And hopefully that you can always go, of course, go view the video and pause it there to look at what I did and listen to the explanation. So compute average is going to be similar. It's got the extra complication that it needs 2 pieces of information, not just one. It tells you what it wants you to do, though. All right, I think that is it. I need to go update this so that that import is put back in there. And other than that, I think I can leave it. So I will post the sample code with the say hellos and the say goodbyes in it. I will upload the videos, and I will see you on Tuesday next week, I hope. Canvas inbox, office hours, Piazza discussions. It takes a while to build up the courage to do it, but I hope some of you will build up the courage to ask questions in Piazza, because I promise you that most of your classmates will have the same question, and they are just hoping that someone will have the courage to humble themselves and ask that question and find the answer that so many people are waiting to hear. So I hope that you will consider being that person who has the courage and the humility to ask that question. Go do a new post, ask that question about the lab or about some concept that we covered, and give us a chance to have a discussion about it. So hopefully that will happen sooner than later. Maybe this week, we'll see. So have a great week. I will see you on Tuesday next week, and hopefully I will run into some of you through one of the messaging channels that we have. So take care, everybody.